on. Here we go. Okay. Let's go with some green. It's starting to be springy out there. We'll go with some grass green here. Okay, so here's what we're working towards. We're working towards solving polynomials of degree more than 2, I guess. Okay. So any quadratic, we can use a quadratic formula to solve it, right? I mean, that's how it works. Factoring only works on about 10% of all the polynomials in the world, so they actually did a study on that. So factoring is not really a very good way of solving a polynomial, even a quadratic. It's not very good because it just everything has to be right for it to be able to factor it and use a zero product property. So a quadratic formula is the way that solves all quadratics. But for cubics and fourths and fifths, we don't have a formula for those. All right, so then, well, how the heck do we solve them? And I don't know, somewhere along the line you should have learned that there's basically 3 ways to solve an equation. All right, one way is by algebra, paper, and pencil. 2x plus 1 equals 5. I'm going to subtract 1, divide by 2. Okay, that's like an algebra, paper, and pencil way, isolating the x. We've done that a lot of times. Then, if you get to something that you're not sure how to do it algebraically, you can always graph it. Well, when you graph anything, the solutions are always going to be the x-intercepts. So whatever the x-intercepts are, those are going to be your solutions. So we've talked about x-intercepts before, and I said, well, x-intercepts and zeros are the same thing. So x-intercepts, zeros, and now we're going to add the word roots, are all the same thing, pretty much. All right? There is some little differences, but we'll talk about that, and they're pretty subtle. So x-intercepts, zeros, and roots are all the same thing. All right? The other important thing that we're going to talk about is something that we played around with on Wednesday. Okay? And that is that I said, okay, let's say that we have a cubic, right, a third degree. And I asked you, how many x-intercepts can I have? Okay, so does anybody remember how many x-intercepts we can have for a third degree?
Two.
We could have 2, right? And I could draw that. And a bounce. Okay, what else? What other situations of x-intercepts can we have? One, yep.
Or none.
Well, that's good. Okay, so 1 for sure. Okay, 1 for sure. Now, the question is, can we have, because here's what 1 would look like. Okay. Is it possible to have none? Right? Is it possible to have none with just a third degree?
Yes.
Well, I don't know how that's going to happen because so this graph is continuing to go down and continuing to go up. So no matter where we slide that up and down, Okay? Now hold on. I said for third degrees, right? For third degrees, there's no way we can have 0 x-intercepts. It's always going to cross. All right, that's what we wrote down last time. Okay? Now, it changes for other degrees. Okay? But for third degrees, no. Now, nobody said 3 because we could have 3. All right? I could draw one of these guys. All right? 1, 2, 3. But we can't have more than 3. We all agreed on that last time. All right. So that means I could have one solution, I could have 2 solutions, or I could have 3 solutions. All right. The crazy thing is that if we have one x-intercept, okay, right here, then I have this turning point here, which is actually significant. Okay? But the bottom line is I could have 1, 2, or 3 x-intercepts. Now what about zeros? Well, it's the same thing. I could have 1, 2, or 3, 0. Well, what about roots? Well, I could have 1, 2, or 3 roots. But here's the catch. If I can have 3 roots, that means I can have 3 solutions. Okay? So, let's hang on to that. And now let's talk about a fourth degree. X-intercepts. Okay, how many x-intercepts can a fourth degree have? Give me some answers on that.
2.
2. Okay, what else?
I guess 4.
I guess 4, yep.
Well, 3.
3, yeah, good. Oops, I want to kind of keep it the same color here. 3. So let me draw some of these. So 2 looks something like that. 4, I can do a 4. 1, 2, 3, 4. And somebody said 3. I can do a 3. 1, 2, 3. Okay. How about 1? Nobody said 1 yet. Can we have 1?
Sure.
Sure. You're right. Absolutely correct. Can we have none?
Yes. Yes.
Yes. Because you could take this W and we can move it up so it never touches the x-axis. Okay? So, we could have 1, 2, 3, 4, 0 zeros. We could have 1, 2, 3, 4, 0 roots. But that implies something that we're going to talk about right here. There we go. And that is this. It's called the fundamental theorem of algebra. And you would think you would think it'd be something different, but this is what it is. And it basically says that a polynomial with a degree of n has n solutions or roots. So the fundamental theorem of algebra says that a polynomial with a degree of n has n solutions or roots. So if it's a third degree, it has 3. If it's a fourth degree, it has 4. All right, so I'm going to give you a second to look at that. Okay. So let's talk about this for a little bit. Let's say that we have that fourth root, or fourth degree. So let's say it comes down here and it comes like this. All right. So here's 2 of my zeros, or x-intercepts. Okay, that's 2 of them. The fundamental theorem of algebra says that there's got to be 4 solutions, not 2, but it's got to be 4. So then the question is, well, if they're not these 2 and there's no multiplicity, what the heck? What could the other 2 be? Any ideas on what the other 2 could be? What kind of numbers they are? Imaginaries. Okay? They got to be imaginary. So if you have a polynomial with only one x-intercept, then your other solutions would have to be imaginary. Okay, if there's no multiplicity. That's what's happening there. Okay? They got to be imaginary. All right, so the fundamental theorem of algebra basically says that if you got a degree of n, you're going to have n solutions. But also, some of those solutions could be imaginary. Okay, they could be. So in this situation here, where we have 2 x-intercepts, that means the other 2 are imaginary. Okay, that's what that says. Now here's one other important fact that comes from all this. We'll put in the same area. If a plus bi is a solution to a polynomial, then a minus bi is also a solution. And if you think about that, that comes from the quadratic formula. Okay, I'm going to change colors for a second here, and then we're going to take a break. So remember, in the quadratic formula, it's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here is the plus or minus part, because this is usually going to be a real number. Very rarely would it not be. And this is where the imaginary number would come from, because that's where that square root of -1 is. Okay? Whereas your I term comes out. So, yeah, plus or minus. So that's where this comes from. So if one imaginary solution is 1 plus 2i, then you know that the other one has got to be 1 minus 2i. So that is kind of the whole fundamental theorem of algebra and how it plays out. So after we take our quick little 10-minute break here, I'm going to show you how we're going to solve these polynomials. All right, before we talk about rationals, we'll see how far we get. All right, so let's come back at about 20 after, and we're going to go to about 10 to 8, and then we're probably going to have to, I want to give you some time to take your quiz. I don't know if it's going to take you half an hour to do it, but I want to give you enough time to do it because it's pretty short. All right, so let's come back at about 20 after and go from there. So here's the type of things that they're going to ask. They're going to say to find the remaining zeros and of course they're gonna give you some other language like it's a polynomial function, coefficients are real numbers, but that's pretty standard. Find the remaining zeros. So they'll tell you what the degree is. So let's say we have a degree of 3, and we'll say that 1 0 is -2. And the other one is 3 plus I. So they're giving you two zeros. They're giving you -2 and 3 plus I. Now, a 0 can be an imaginary because the reason why it's called a 0 is if I put that value, whatever that number is, in for x, I will get 0 when I'm done. Okay? So you could put 3 plus I into a polynomial, for x, and it's going to give you a value. All right, you can actually use synthetic division on an imaginary. It's messy, but you can do it. Okay, either way here, we have a degree of 3. So we know we have 3 solutions. I got 2 of them right here. Can anybody tell me what the third one is? Put it in the chat or just tell me.
3 minus I.
Yeah, good. I like it. It's in unison too. That's even better. 3 minus I. That's it. That's all they're asking you to do. Okay, they're just saying, hey, find the remaining 0. You don't have to write anything. You don't have to do anything other than find that remaining 0. All right, let's look at one here. Let's see that our degree is 4. Okay, I have a 0 of 3, and I'm going to say that the multiplicity is 2 on that. And then I'm going to say that 1 minus I is one solution. Okay? So, what does the other one have to be?
1 plus I.
Exactly. So you might say, but wait a second, isn't that just 3? But remember, this is a multiplicity of 2. So that one counts twice. All right, so if you have a multiplicity of 2, that means that particular solution takes up 2. All right, because what that looks like, all right, is something like this. So let's see, 0 at 3. So we would have something like this. All right, and I really don't know what this looks like, but it's going to be something like that. And right there at 3, that's that multiplicity of 2, so that takes up 2 solutions, or x-intercepts, or roots, whatever you want to call it, zeros. All right. Okay, now the next thing that they're going to ask you to do is actually write a polynomial. So we're going to write a polynomial with zeros of, and then we'll go ahead and do it. Now, it doesn't say to put it into standard form. Okay, so we can write it in factored form here. And you can use y equals or f of x. Oh, let me give you some information first, right? So the degree is 3. Okay, and I have 1 0 of 2, and I have 1 of, just say I. Right, so then, to write this, I'm going to go x minus 2. Okay, there's my taking care of it. Now I got to put the other one in there, x minus I. Now what do you think the next one's going to be?
X plus I.
Yep, x plus I. Good. Do we have to do anything else? Nope. I don't have to multiply that. It doesn't say put it in general form. It just says write it out. Okay, write it out.
So do we always have to put x minus I and x plus I?
Yeah, right? Because, again, you're going to have negative I as that other solution, right? Because if plus I is 1, the negative I has to be the other. And vice versa. If you have negative I, then you know plus I's got to be 1. You're always, and those are called conjugates, and I probably forgot to mention that. Those are called conjugates. So when you have, here, let me say that here, and I should have said it. If I have A plus BI, then the conjugate of that is A minus BI. Okay. Now, so I'm pretty sure at 95 you'll learn about imaginary numbers. So if you had 95, you should have learned that, and you should have learned that this is a conjugate. Okay.
Okay, thank you.
Yeah. Okay, same topic. Let's kind of keep going. So let's say we want to write an f of x. All right, this one's going to be a degree of, let's go with 4. Let's go with a degree of 5. We haven't done anything with that. We'll say that we have a 0 of 2. We'll make that a multiplicity of 2. We'll say we have another 0 of 1, and then we're also going to have a 0 of 3 plus 2i. All right, so now we're ready to write it. Parentheses, x. So give me something right there. X what?
Minus 2.
Yep. But it's a multiplicity of 2, so that means it's
Squared.
Good job. Okay. What's another one?
X minus 1.
Good. Good. And another one?
X plus 3 plus 2i.
Okay, that's pretty good. So here's what I would suggest we do here. Let's go x minus, and I'm going to put a little
3.
parenthesis there and go like that. Okay. And then, so you were pretty close.
The same thing, but
yeah.
Plus.
Right. So it'd be the same. Well, actually, no, this is still going to be a minus here. Look at that. I screwed that all up. So it's going to look like that. The only thing that changes is the minus sign in there. Okay, so however, if you move that negative inside, you're going to get negative 3 plus 2i. So you were, pretty dang close there. All right. So that's how that looks. And again, we don't want to do anything more than that. Okay? We don't need to write it in standard form. Okay, now we're actually going to solve some of these. So I'm thinking that these that I wrote down the other day are going to be okay. So let's try solving this one first. So the first thing I want to do when I solve these, okay, is graph them. I always want to graph them first because I might get all three answers just from graphing. And by the way, we want to find exact answers here. Okay? We want to find exact answers. And they don't really specify that, but that's what we're looking for. So we don't want to have, if we have a decimal that repeats, that's okay. But we don't want to have something like 2.1348 and it just, we want it to be an exact number. So let's graph it first. So go ahead, put that in Desmos, and tell me what you get for x-intercepts.
I got -2, 1, and 3.
Okay, so see, there's our answers. -2, 1, and 3. We don't have to do anything anymore. That's our answers. Okay, -2, 1, and 3. Okay, good. There's our answers. So let's kind of keep going here. Let's try this one. I don't know if this one's going to work out real well, but let's try it. That's a 22, not a 23. These all got to be set equal to 0, or else they don't work. So see if we can come up with any x-intercepts for that one.
I got -1.486.
Is that the only one?
Yes.
Okay, so that one's not a very good one then. Okay. Let me erase it. I'll have another one that's better for us.
Oh, actually, I wrote 14, not 15. Maybe that's why.
Oh, okay.
I just figured out. So it's actually -1.5 and 2 and 2.25.
Okay. So that one still doesn't. Those are all the answers. So you don't have to do anything. So let me try this one up here. Let's do this one. Okay, graph that one and see what the x-intercepts are. Now remember, we want them to be exact, so I need a nice one.
Well, again, I got -1.772 and -1.
Okay, so -1 is the one we're going to pick, okay? So those other one, it's not exact. So we're looking for an exact solution. So here's what we're going to do. We're going to take this here and we're going to use synthetic division with -1. So we're going to put that there. So 1, -4, -17, and -12. Now we know that because -1 is an x-intercept, that remainder has to be 0. So if your remainder is not 0, then you know you made a mistake someplace. And we don't take the opposite here, okay? We're just using that exact x-intercept, whatever it is. All right, here we go. 1, -1, -5, 5, -12, 12, 0. There's my synthetic division. Okay, now when we reduce it down, right? So we started with a cubic. I divided by -1, so that reduces the power down to 2. So this would be x squared minus 5x minus 12 equals 0. Now I opened up with saying you can solve any quadratic by using the quadratic formula. So let's use the quadratic formula on this. So I have -b plus or minus square root b squared minus 4ac all over 2a. Remember, so a is 1, b is -5, and c is -12. All right. So I'm just going to do this one by hand, but you know, the problem is if you use Desmos, you're not going to get exact answers. So that's why we have to kind of use this one by hand. So let's see, I got 4 times 1 times -12 divided by 2. So 4, so that's going to be 48 divided by 2. So here's my other two solutions right here. Remember, I have to have 2, right? Because that's a cubic, it's the third degree. One was the x-intercept, and then the other two are these. And I can't break that 73 down. So that's it. There's my two answers.
So in the homework problems, so first we'll put it into Desmos, and if we get a few answers, but one isn't like a clean number, then we have to solve it this way.
Yeah, so good, I like the word clean. Yeah, so you want a clean number, right? Use synthetic division, break it down into a quadratic, and then solve it out using the quadratic formula. Yep, that's exactly what you want to do there. Okay, we're going to try now. We're going to do some more here, so don't worry. All right, again, we're going to solve, and here's another one. Okay, go solve that one. Did you get an x-intercept? Yeah.
Just -1.
That's right. So here we go. So we're going to go -1. 1. Now again, I don't have an x squared, so that's a 0, 5, and 6. I know what the remainder is going to be, but I'm going to work through this. So I'll drop down to 1, negative 1, negative 1, 1, 6, negative 6. There's my 0. Good. I'm happy because that's what I need. This is now a quadratic. 1x squared minus 1x plus 6 equals 0. Okay, so I'll stop for a second so you're kind of writing this down and taking a look at it. Okay. So let's use the quadratic formula. X equals, all right, A is 1, B is negative 1, C is 6. So opposite of B, so that's 1 plus or minus square root. 1 squared is 1 minus 4 times 1 times 6 all over 2. 1 plus or minus the square root. Here's where it's going to get messy. So I have 4 times 1 times 6, so that's 1 minus 24 over 2. And there's where my imaginary comes in, right? Because I'm going to get a negative 23. So that means I'm going to get an I on the outside and a square root of 23 on the inside over 2. Guess what? There's my other two solutions right there. All right, so you should have noticed that you had one x-intercept. So in your mind, you're going to say, wait a minute, this is a degree of 3. So I know that the other two have to be imaginary. Okay, they got to be, because you've only got one x-intercept. All right, so then you know that the other two, they got to be imaginary. So right away, you should have an idea that's what's going to happen. Questions on that one before we do another?
Oh, sorry. How can we put the I in front of the square root of 23?
So whenever you have a negative square root, like, so it was 23, I guess. All right, so that means the square root of negative 1 times the square root of 23. And the square root of negative 1 is what I is equal to. So that's where the I comes out in front.
Yeah, I've always been confused about the I's in high school, and that's summarizing it.
Okay.
Thank you.
You're not the only ones that ever been confused about I's, because they cause a lot of problems. But yeah, I is equal to the square root of negative 1. So basically what you're doing is you're just taking that negative and replacing it with the I out in front. Other questions on that before we do the next one? Okay, now we're going to try this one. All right. This time this is going to be a 4th degree. Okay, go find me x-intercepts. When you get them, let me know.
I got -1 and 2.
Okay, so now we got 2, right? So what do the other two solutions have to be?
Imaginary?
Yep. We know we're going to have 4. Again, that's the highest power. That's my degree. Okay, so let's go get them. So let's use synthetic division. Now, it doesn't matter which one you pick. All right, let's just pick -1 just for kicks here. I don't have to worry about any zeros this time. I can just go after it. All right, 1, -1. See, you're going to get really good at synthetic division after this because you do it so much. And you know you got to get a 0 there. Because if you didn't, then you know you had a problem. All right? Okay. So now let's think about this. All right? We've divided by -1. So we've reduced this down 1 degree. So what is this now? What degree is that going to be?
3rd degree.
Right. And we can't solve a 3rd degree. But the good news is we have another x-intercept. So we can go like this with the 3rd degree. So we do it again. 1, 2, -3, -6, 7, negative. Ooh, we got something went wrong here. Was that? It was 2, -3, -6, 7. Oh, it's a positive 14. Ooh, I was worried for a second there. And there we go. All right. Now, this is a quadratic, right? So I can go ahead and solve it. But I had to go down and do it twice, or else it wasn't going to work. So x squared minus 3x plus 7 equals 0.
What if we wouldn't have like number 2? Like if we would have only one clear number?
Then it's going to take a little bit more than what we're going to be doing in this class to figure that out. Yeah, I mean, you have to use other methods. So the ones that you're going to have are going to be that way. They're going to have 2 nice x-intercepts, and you're going to be able to work with them. Okay.
That's good. Okay.
Yeah, you got to have some information there. Yeah, you can divide them with a complex, which is probably what I should show you. I don't know if there's any, you have any like that though, so I think you're okay. Oh, no, you don't. I mean, I'll check, but I don't think you do. Oh, let's see what we got here. 3 plus or minus the square root of b squared minus 4 times 1 times 7 over 2. 3 plus or minus square root. So let's see what we got here. 9 minus 4 times 1, that's going to be 28. And 3 plus or minus negative 19. So the I is going to come out in front. And over 2. And there's my other one. Okay.
So we always have to put I before square root.
Yeah, that's how you write a complex or imaginary number, yes. So I'm looking at these problems, they're giving you, let me show you kind of what this looks like. So this is number 23. Okay, I think this is one of the ones you have to do. I'm not 100% sure. Yes. So they give you this problem here. And they say that 1, 0 is 2i. Okay. And it says find the remaining zeros. Okay. So if one of them's 2i, what's another one? Automatically. Negative 2i. Good. Okay. So my thinking is that if you just take and graph this, it should give you the other one. All right, and it should be clean. Okay, so graph it and see what the other x-intercept is. Does it come out nice?
I got 4.
Yeah.
2.
So I think you'll be okay then. All right, I don't think you'll have to do any synthetic division with an I term. Okay? Because I'm looking at these and I'm hoping that they aren't. Okay, and I only gave you a couple of those, so you're probably pretty good to go there. The other thing that's going to ask you to do is write them in factored form. I would just solve them. Okay, and let's leave it at that. And then we can talk a little bit about factored form on Wednesday, but I'm not going to worry too much about that for now. So as long as you can solve them, you're good. So that's everything from 3-3, which means we didn't get to 3-4, which is okay. We're going to bump that to Wednesday, which is okay because 3-4 and 3-5 are pretty much the same thing, and we can do all that and still have a little bit of time to make up some stuff. But keep in mind that if you got anything out there to be made up, that I did give you that little block of time there to do it. But if you got a couple of quizzes to do, you might want to take the time to get them done between now and Wednesday. Okay. So that's what we got. So I'm going to bump 3-4 to Wednesday, and because I want to give you time for your quiz. Any quick questions before we start the quiz here?